Good morning, children. Today, let's continue with the lesson Statistics with the second topic named Graphical Representation of Data. As we have discussed earlier, statistics deals with collection of numerical information and we call them as a data. The second concept is how to represent that data. The first way of representation is by the tabular form, which we have already done in exercise 14.1. The second method of representation of data is by the graphical representation, and there are three different ways by which you can represent a data. The first graphical representation is by a bar graph. The bar graph you have already familiar in your previous classes. What do you mean by representation of data in a bar graph? You can recall here as a bar graph is a pictorial representation of a data in which usually the bars of uniform width are drawn in equal spacing between the bars. On the x-axis will represent a particular variable. The values of the variable are shown on the y-axis and the height of the bars will represent the value of the variable. In this particular example, I have represented a data as the birthday month of a few students in a class for the first 4 months of January, February, March and April. So the variable here is the month that is marked along the x-axis and the value of the variable, that is the number of children whose birthdays fall in the month of January, February, March and April will be marked on the y-axis, or it is the value of the variable. Why we are calling on the x-axis as variables is the questions will be based on different concept. You can also imagine a question as the expenditure of a family on different commodities in a particular month. So we will be marking the commodities as the articles what we are buying in that particular month for which is needed for that particular household, and the expenditure will be marked in rupees on the y-axis. That is why the x-axis will have varying quantities and so we call them as a variable. And now you can read this data as in the month of January 4 students have their birthdays. In the month of February, 2 students. In the month of March, 1 student. And in the month of April, 5 students have their birthdays. So, by the graphical representation, the data is very clear and the interpretation of data also becomes very easy. The second graphical representation is by using a histogram. What do you know by a histogram, or what do you do by this is, it is always used to represent a frequency distribution table where you have class intervals and the main highlighters, the class intervals should be continuous because histogram represents a series of rectangular bars with equal width. Thus, a histogram is used to represent a frequency distribution table with continuous class intervals. So when you are given a data with an inclusive class interval, make sure that you are converting the class intervals into an exclusive one, that is histogram will be represented for continuous class intervals. It will be a number of rectangular blocks with equal width. Let's take the example of this data representing the marks scored by 20 students in a test. The first concept is to check whether the class intervals are continuous. The class intervals are continuous as 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. So if you have to represent this data on a histogram, the two perpendicular axes, the x-axis and the y-axis. On the x-axis you will be representing the marks. On the x-axis will represent the marks and y-axis represents the number of students. And the class interval starts from 0, so the origin is 0. You will mark with equal units the upper limits and lower limits, that is 0, 10, 20, 30, 40 and 50. It includes all the lower limits as well as the upper limits. On the y-axis with a particular scale, the minimum is 2 and the maximum is 6. So you can take with 1 unit as 1, 2, 3, 4, 5, 6. The first class of 0 to 10 will have 2 students, that is from 0 to 10 there are 2 students. So you will draw a bar with the frequency of 2, that is 0 to 10 represents 2 students. 10 to 20 has 3 students. So we will have the rectangular box with the frequency for 3 students. Then 20 to 30 will have 5 students. 30 to 40, 4 students. And 40 to 50, 6 students. And this will be the format of a histogram. It will be continuous rectangular boxes of equal width as we have equal class intervals. And to complete this, you should always mention the scale factor what you have taken on the x-axis and y-axis. On x-axis, 1 centimeter is equal to 10, 20, 30, 40, which represents a difference of 10 units. As well as on the y-axis, the scale is 1 centimeter is equal to, you have taken the units as 1, 2, 3, 4, 5, that is a difference of 1 unit. And the heading, histogram representing the marks of students. You have to always give a heading to the histogram. That is x-axis, on the x-axis you will mark the class interval, y-axis you will mark the frequency, and a scale factor should always be mentioned. That is, for a histogram, on the x-axis, class intervals, on the y-axis, frequency with a scale, with a scale factor. And the important note is the class intervals should be continuous. Class intervals to be continuous, or it should be exclusive class intervals. I will mention as the frequencies with a particular scale factor. The third graphical representation is a frequency polygon. For a frequency polygon, there are two methods of expressing it as along with a histogram or a frequency polygon alone. Let me explain the first method of marking or drawing a frequency polygon with a histogram. The histogram we have drawn in the previous example is taken. The data represents the marks scored by 20 students. To draw or to represent it in a frequency polygon, we have to take the mid value of each class. That means after drawing the histogram, plot the mid value of each of the rectangular box which shows the mid value of the class. You can plot the mid values, and by using a scale you will join the consecutive mid values. That will give you the joining of the mid values. But the word is frequency polygon. So the graph has to be a closed figure. Now, since you are taking the mid values of each class, you have to select one more class next to the last class of the histogram. What will be the mid value of that class? One of the endpoint will be joined here. And for the joining purpose of this, you have to extend the x-axis to an imaginary class where there is a negative value. And since the question is based on the marks and there are no negative marks, you can consider the mid value, but you will join it. But the frequency polygon is from the point where it is touching the y-axis. The polygon will be, let's name it as O10. A, B, C, D, E, F, G. The polygon will be O, the figure represented by O, A, B, C, D, E, F and G. That is, the point where it is touching the y-axis will be joined with the origin, and the polygon will be O, A, B, C, D, E, F and G. So a frequency polygon will always be a closed figure. And now, how to draw a frequency polygon if there is no histogram or alone in a graph paper? I'll be showing it as the next example. Let's see how to represent this data in a frequency polygon. The class is given as continuous intervals 140 to 150, 150 to 160 and so on till 190 to 200. And the frequency 5, 10, 20, 9, 6 and 2. So 20 plus 30, 35, 35, 36, 37, 37 plus 6, it is 43 plus 9, 52. And now, if you review the histogram with the polygon, we marked the mid value of each class. The mid value of each class is called as, the mid value is given as the class mark, which will be calculated as upper limit plus lower limit divided by 2. That is, the mid value of a class is called the class mark, and we always find the class mark as upper limit plus lower limit divided by 2. So let's check the class mark of the first class, 140 to 150, the class mark of the first one. 140 plus 150 is 290 divided by 2 is 145. So the first class mark is 145. The second class mark 150 to 160. The method is 150 plus 160 divided by 2, or it is 310 divided by 2 is 155 and so on. But since the class intervals are continuous as well as they have the class size of 10, what you can do is, after getting the first class mark, you can add 10 to each of the preceding class mark to get the successive class marks. That means 145, 155 plus 10, 165 plus 10, 175, 185 and 195. Double check between 150 and 160 is 155. Between 160 and 170 is 165, and so it is correct. So now, since a polygon is a closed figure, you need two class marks which is ahead of this particular class as well as which is beyond this particular class. Therefore, the class marks of those ones will be 135 and the class mark of the next class will be 205. It's very important to make this note as a polygon is a closed curve. And now, how to draw or how to represent this in a graph paper. On the x-axis, we plot the class mark, and on the y-axis, we plot the frequency. And then on the x-axis, class mark, on the y-axis, the frequency. And when you see the difference between 0 and 135, it's a difference of 135 units, whereas each consecutive one will be 10 units different. To particularly show that, you can just put a symbol which is called a kink, which shows that there is a difference between only in the first representation. And then how to plot the point is 145 with 5. The point 145 with 5 will be approximately taken and you will represent it. The next one 155, 10, 155, 10. The next point 165, 20, 165 with 20, 175 with 9, 175, 9, 185, 6, 185, 6, 195, 2, 195, 2. And by using a scale, you will be joining these points. Since the polygon is a closed figure, here you have a measure, you have a class mark of the previous class, that is 130 to 140. So you can join the frequency polygon with marking of 135 as well as the other one, the preceding class 205. And you will give a heading frequency polygon. Frequency polygon of the class, or if there is any particular detail in the question, you can mention in a brief way. Then the scale factor is on x-axis 1 centimeter is equal to, as you have provided a kink, you have to take only the difference 135 to 145, 145 to 155, that means it is a difference of 10 units. And on the y-axis, a scale factor of 1 centimeter is equal to, you have taken as 2, 4, 6, 8, 10, that is the difference. 4 minus 2 is 2, 6 minus 4 is 2, that is, it is a 2 unit scale. So, what is the specification of a frequency polygon? What you should remember for a frequency polygon is, on the x-axis, it should be the class mark. On the y-axis, it is the frequency with a scale factor. And what is the concept of mid value or class mark is, it's always the upper limit plus lower limit divided by 2. Exercise 14.3. One example each for bar graph, histogram and frequency polygon. We will work out. Question based on bar graph. Question number 3. The question says that the data shows the seats won by different political parties in the polling outcome of a state assembly elections. The political parties are A, B, C, D, E, F and the seats won. So the x-axis will represent the political party and the y-axis will represent the number of seats, and you have to plot equal with the different political parties. You have to form rectangles of equal width here. A 75 units, 75 seats. You will join it. Then political party B with 55. B. Then C 37 seats, 30 with approximately 7. If you plot in the graph paper, you will be getting the exact place where the frequencies are marked. 37, 29, 29, then 10, 10 units, 10 votes, and F with 37. And the bar graph representing seats won by different political parties. The scale factor of the y-axis can be mentioned. Scale y-axis 1 centimeter is equal to 10 units. So this will be the example for bar graph. Question number 5. The following table gives the lifetime of 400 neon lamp. The data is given to you. Represent the given information with the help of a histogram. How many lamps have a lifetime of more than 700 hours? So let's plot first the table. On the x-axis, we have marked the lifetime in hours. On the y-axis, the number of lamp. Then, since the gap of 300, we have put a kink to show that between the first and the first unit, there is a difference of 300 units, whereas the remaining each is spaced between 100 units. Let's start drawing the histogram. 300 to 400, 14, approximately 300 to 400. 14 lamps. 400 to 500, 56. 56, 500 to 660. 86. 86. Next goes 74. 74, 62. 58. and 900 to 1000 is 48. Maybe 48. Histogram representing the life in hours of 400 lamps. And the second answer is how many bulbs are having, how many lamps have a lifetime of more than 700 hours. More than 700 hours, you can see from here that more than 700 means it is 74 plus 62 plus 48. 74 plus 62 plus 48. 8 plus 2 10 plus 4 is 14. 1 7 plus 1 8. 8 plus 6 14 plus 4 18. 184 lamps have lifetime of 700 hours or more. This frequency will give you that. From the graph you can read in that way. Question number 6. The following table gives the distribution of students of two sections according to the marks obtained by them. Represent the marks of the students of both the sections on the same graph by two frequency polygons. From the two polygons, compare the performance of the two sections. So for that, the data is written here. For a frequency polygon, you have to mark the class mark on the x-axis. So calculate the class mark as 0. It's a mid value between 0 and 10 means 0 plus 10 divided by 2 is 5. Then the class size is 10. So 15, 25, 35 and 45. Here also it is 5, 15, 25, 35 and 45. Since we have to mark it on the same, let's mark it as 5, 15, 25, 35, 45. As always, we need one more class for the frequency polygon to be closed. And here an imaginary class as -5. Then let's mark the frequency as, since it is in the same graph paper, 3, 9, 17, 12, 9, we have to consider all the values before taking the scale. The values are almost similar. We can take it as with the 2 units, 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. So that you can easily plot the points. The first graph 5, 3. Let's plot the points as 5, 3. 5, 3, 15, 9, 15, 9, 25, 17, 25 with 17, 35, 12, 35 and 12, 12, 45 with 9, 45 with 9. And the mid value of the next class is 55. Here, since it is going to an imaginary left side, let's bring it till the origin. The mid value of that class is here. This represents the first frequency polygon. For the second polygon, 5, 5, 5, 5. Then the point 15, 19, 15 with 19. The third one is 25, 15, 25 with 15. $25, 15. The next one will be 35, 10, 35, 10. And 45, 1, 45, 1. Let's join it. As well as here. We'll join to the mid value, but the graph will be closed with the measure like that. Polygons representing the marks of two sections of a class. Scale x-axis 1 centimeter is equal to 5 units and y-axis 1 centimeter is equal to 2, 4, 6, 8, 10. That means it is 2 units. On the x-axis you mark it as the class mark, and the y-axis the frequency or the number of students. Here you can also write it as mark and the number of students.